This is from Maze B, the one passed out today. So the starting question is here. It's 2 sine squared x. I'm going to write it here and show my work. Equals 1 minus sine of x. When you have a problem, an equation that has multiple trig terms that you cannot combine, so they're not like terms. So notice this sign is squared, this sign is not. I cannot add those together, right? It's just like having x squared and x. I can't combine those in an equation. When that's the case, or if it was a different, like you had a sine and a tangent, you can't combine those. You get everything to one side of the equation, set the equation equal to 0, and try factoring. So I'm going to move everything that's on the right side of the equation to the left. So the 2 sine squared x stays as is. I'm going to add the sine x over and subtract the 1 over. And now it's equal to 0. I moved everything from the right side to the left side. Now I can see, and hopefully you can see, it's a quadratic form trinomial. You have sine squared, sine, and a constant. This mimics, it's the same thing as this. It's just instead of x and x squared, it's sine of x and sine squared of x. Do y'all see the symmetry there, the similarity? So I'm going to solve this the same way I solved this in Algebra 2. In Algebra 1, actually, maybe. I don't remember if in Algebra 1 y'all had a values other than 1, but definitely in Algebra 2. Okay, so quadratic form factoring. And this is what I reviewed in the notes last week. I showed y'all a shortcut to grouping using that X method or X box, whatever you call it. Y'all take, this is ax squared plus bx plus c form, right? So the X method or the X box is taking your a times c and putting it in the top, and your b and putting it in the bottom. So in this case, that's 2 times -1, so that's -2, and b is an understood 1. You look for factors, what multiplies to -2 that adds to 1, and that would be +2 and -1. You can do grouping. Grouping is fine. The shortcut I showed y'all, though, is to take the value that's being squared over here. So the 2 sine x is that lead term, and put it over those. If you can reduce, reduce, which here we can reduce those 2's. Here we cannot. So sine x, and then that's an understood 1 underneath there, a +1. So your first factor is sine x plus 1. The second factor would be 2 sine x, and then the denominator is a -1, -1. So once you have it factored, I think y'all are okay with split and solve, right? I think it's just some of the factoring you may be struggling with. I know the bell's about to ring. I've answered a lot of these questions individually for y'all. I'm going to go ahead and just pick a few random ones here. After the bell, I'm going to keep recording and I'll post this. I'm not going to go through the whole process, the split and solve part, because I don't have enough time to record a video before my next class. But during the passing period, I can just go over a few of the factoring steps just to review, and I'll post that for y'all. Yeah, I'll finish just this one. So when you take, once you have your equation factored, you set each factor individually equal to 0. Okay, and you solve. So on the left side, I would have to subtract the 1 over to isolate the trig value. Over here, I would have to add the 1 and divide by the 2. So it would end up being 1/2. So then it's unit circle knowledge. Where is sine 0? That's the y value. Where's the y value 0 on our unit circle? At 0 and pi. Okay. Now, this interval only wants the answer from pi halves to 2 pi, so it doesn't want the 0. So we don't use the 0. Okay, on this side, where on your, y'all have a good day, where on your unit circle is sine 1/2? Sine is 1/2, the y value is 1/2 at your pi 6 or 30-degree reference angles. And it's positive in quadrant 1 and in quadrant 2. But again, the interval that it's asking for the answers on is between pi halves and 2 pi. So it doesn't want quadrant 1 answers. So again, I'm not going to use this answer. So the only solutions I'm getting for this one are not. Oh, I see 5 pi 6. 3 pi halves. Did we solve something wrong? Hang on.
I think it's supposed to be sine of x equals -1.
Sine of x
Equals -1.
Oh, I didn't even subtract the 1. Good catch. Thank you, Ricky. I said solve for x, solve for it, and I said subtract it over, and then I didn't subtract it over. Okay, thank you. Okay, so then that -1 over here, it's -1. So sine is -1 at 3 pi halves. So those are the two solutions that are in this particular interval. So I follow that path, and then this would be the second problem I do. Okay. All right. Hey, I'm going to record for a few minutes, and then I'm going to go. You can go to your mom's if you're going there now. Okay, so let me pick out a couple of extras to try. Do you have one in particular, Will, you would suggest? I'm going to do this tangent one right here, this tangent to the 4th power. Yeah. On your path, you should have followed this way down. Oops. Okay, this one, though, is very similar. You just need to move the terms over and you get your trinomial and you factor. Okay, this one is different. It's not a trinomial. So let me review that one with y'all. If I have something to the 4th power, I need to remember that the square root of x to the 4th would be x squared. So the square root of tangent to the 4th would be tangent squared. This is a special type of factoring. This is your difference of two squares. Okay, so you have two values that are perfect squares that you can take the square root of, and it's the difference. They're being subtracted. Okay, so difference of two squares has you take the square root of each term. So the square root of that one would be tangent squared. So I put that in both locations, in both binomials. And the square root of 1 is 1. Okay, you do 1 positive and 1 negative. Now I'm not done factoring. I could go ahead and split and solve here though, if I wanted, or I could keep factoring this one. This one is done. I can't factor this any further. But this one is a difference of two squares still. So it can be broken down into two other binomials, because if I take the square root of tangent squared, that's just tangent. And if I take the square root of 1, that's just 1, and I do 1 plus and 1 minus. Now this term doesn't go away, it's still here. Okay, and then I can solve. Now when I do this, when I set each of these equal to 0. This first one, when I set this equal to 0, and I solve, I subtract that 1 over, I end up with a -1, just like I did up here. Right here, when I subtracted that 1, I ended up with a -1. Okay, I cannot take the square root. That's the next step, is to take the square root, but we can't take square roots of negatives. You get imaginary numbers. So there's no solution on this from this factor. Okay, so there's no solution from this factor. So I'm going to try the next one. Okay, and then the last one. Okay, so on both of these, when I move the constants over, I'm subtracting one here, so it ends up being a -1. And over here, I add it over, so ends up being a +1. Okay, so I'm asking myself, I'm thinking about my unit circle. Where is tangent -1? So tangent is 1 at your 45 or pi4 reference angles. Okay, it's negative in quadrants 2 and 4. So the pi4 reference angle in quadrant 2 and in quadrant 4, and then +1, that would be tangent's positive in quadrants 1 and 2. So in quadrant 1, that's just pi4, and in quadrant, 1 and 3 is where it's positive. In quadrant 3, it would be 5 pi4. You go back and look at this interval where they want the solutions to come from, and they want it to come from between pi halves and 3 pi halves. So that's only quadrants 2 and 3. So they only want the solutions from quadrants 2 and 3. We're not going to use the solutions from quadrant 1 or quadrant 4. So if you end up here, when you're leaving this problem in the maze, you would follow 3 pi4 and 5 pi4. So right here. So this would be the next problem that you go to. Okay, so that bell just rang for the next class. So I have to stop this video here. I only know I went through 2, but I'm going to post the completed key of all of the problems you should go through on here that shows this work. So hopefully that will help you when you're studying tonight too.